Now we'll tackle the mixture problems that we know and love so well from science class. So let me just remind you what it means for a 30% lime juice solution. I'm just going to go to Google here. And I don't know what page this is, but that's a great picture of a mixture. So pretend that that yellow stuff, whatever that is, potassium something, pretend that that's lime juice, right? So if you have water, that's the clear stuff, right? And lime juice, the mixture means that it's 30% of what's in that beaker is lime juice, and then the remaining 70% is water. That would be a 30% lime juice solution. But I'm going to take a little picture of that. Hold on one sec. There we go. All right, so again, that means that the beaker has or is 30% lime juice and 70% water. Okay, that's what it means to be a 30% lime juice solution. Okay, so if that's what solutions mean, then let's think about this for this problem. How many quarts each of a 16% antifreeze solution and a 24% antifreeze solution must be mixed to make 8 quarts of an 18% antifreeze solution? And again, this is the kind of thing that you do in science, of course, but also in shops and stuff. Like I've seen my father-in-law do this, where you have, you know, one jug of a certain percentage of, you know, motor oil or whatever, and then probably not motor oil, but he'll have another jug of a different percentage, and he has to mix them. They do the same thing in paint stores too, honestly. Okay, so let's see here. We need to have our 5 steps because this is another traditional type problem. So let me go get those pictures and I'll be right back. All right, the first thing we're going to do is figure out some variables. So you can see that we have 2 types of solution in here. We have a 16% and 24%. They must be mixed, right? So how many quarts each? See that? They're asking you what they want. So they're telling you, you know, hey, we want X and we want Y. So we're going to let X be equals how many quarts of, or I could just say quarts of 16%, say. And then we're going to let Y equal quarts of 24% antifreeze. All right, great, wonderful, marvelous. And now the fun begins. We've got to make some equations. All right. Well, we have a couple things roaming around. We have this percent business, right? So if you take the low percent and the high percent, you're going to add them up somehow and get the middle. It's going to be very Goldilocks of you, right? You're going to have the 2 low and the 2 high, and you're going to add them up and you're going to get just right, right? So we're going to have a percent equation kind of going on. And then we're going to have a quantity equation going on. The 2 of them are going to give you the equations you need. Now, the percent's actually the harder one. It's easier to spot in the sentences, but it's harder to spot in terms of what to do. So let's look at the quantity. The quantities kind of come right from here. The fact that you have 8 quarts. Okay, since you have 8 quarts, you know that X is how many of 16%, and then Y is how many of 24%. Together, you've got to make 8 quarts total. There's your total. Then you need your percentage, and this is the harder piece, because you need, oops, I pressed the wrong keys. All right, so you need your 16% and your 18 or your 24% to add up and somehow equal 18%. That's where it gets tricky. So you can say, okay, look, I want 16%, but I want X quarts of it. So like, you know, if I used 4 quarts, it'd be 4 quarts times 16%. The rest is just water, right? So only 16% of it's actual antifreeze. Then I'm going to add to that 24% times Y, right? Because if Y is how many quarts of the 24% I use, then how much antifreeze am I actually getting? That's 24% of the Y quarts. So if I used, you know, I don't know, 4 quarts there, that'd be 24% of 4 times 4 equals. Now here's where it's different from the money. Interest, when we did interest, we would just say, oh, it equals this and we're done. But that's because when we were doing interest problems, we were getting a whole dollar amount. Look, it was 416 total in dollars. It's already figured out how much total you're getting, right? It isn't figuring out the average percent. It's not saying, you know, at the end you earned, you know, 4.23% on your investment. It doesn't say that. It just has a dollar amount. It's not a percentage, it's a dollar amount. See that? But down here in the mixture one, they didn't give us a dollar amount. They didn't give us you know, and you'll have 7 quarts when you're done. It doesn't say that. It says you want 18%, but it's 18% of 8, right? So you're going to have to multiply by 8, which, by the way, if you do that, 0.18 times 8, you get 1.44. That right there is with the problem that most students make with this, right? So make a note to yourself, right? We can't have, let me see, you must multiply percentage, 18% times 8. Right? Now, why? Well, you want to keep the units consistent. This is percentage times quarts. This is percentage times quarts. You need it to be percentage times quarts when you're done. Right? Cool. And again, you didn't have to bother with this one because they'd already figured it out for you. They already said, you know, dollars times percent, but they've already figured out what the dollars times percent is going to be. That's how you get the interest rate to be 416. They don't say, and then you'll have $4,000 at 41.6%. They don't say that. They say, oh, you're going to have $416, period. Right? But we're not given that luxury down here. So you've got to multiply. Right? That is the number one mistake students make with this problem, is that they won't multiply. It makes no sense to say, okay, look, I'm going to take 16% of 4 quarts and 24% of 4 quarts, and somehow I'm going to have 18%. Just 18%. like that makes no sense. Like if you're going to make, you know, 16% 4 quarts and 24% 4 quarts, I need 18% of 8 total, because there's 8 total quarts in this thing used all together. All right. And again, this part came from, came from all sorts of stuff. It namely came from the 16, the 18, the 24, these pieces. And honestly, the 8 as well. That's involved in this. Of course, now that we have the 2 equations, it's not that hard to do. But you got to get those 2 equations first, right? Okay, now you can do this with substitution or elimination. Either one will work just fine. Personally, I think substitution's kind of easy around this. So if you say, you know, okay, x plus y is equal to 8, that means that, and it doesn't really matter which variable you get rid of. So I'll just get rid of x. I don't know. X is equal to 8 minus y, right? Because you could subtract y from both sides. Right, I'm going to use that fact and I'm going to substitute it into the bottom equation, the green equation, if you will. So that green equation was 0.16x plus 0.24y equals 1.44, because we multiplied that part. So now that I know that x is equal to 8 minus y, I can just say 0.16 times 8 minus y plus 0.24y equals 1.44. All right, 0.16 times 8 is 1.28 minus 0.16y plus 0.24y equals 1.44. Sorry, I'll make this a little bit bigger. There we go. And then that makes it, let's see, 1.28, 8 plus 0.08y equals 1.44. Then we just need to subtract 1.28 from both sides. Oops, 1.28. Which leaves me 0.08y is equal to 0.16, right? Do that subtraction with a calculator. Then divide both sides by 0.8, or 0.08, oh, excuse me. So 0.08. And you're going to get that y is equal to 2. Now, I know this one worked out whole numbers, but that will not always be the case, so be careful, right? All right, so y is equal to 2. We still have to solve for x, but x is going to be super easy because we know that x is equal to 8 minus y. Oops. There we go. 8 minus y. So now that I know it's 2, that's equal to 8 minus 2. 8 minus 2, which is equal to 6. Done. So now we got to give it some units and finish it off, because numbers alone are not enough. So I agree that y is 2. I'm going to underline it just so you can see it. I don't want to box it because it's not really the answer. It's just the step right before the answer, right? So 2 and 6. Now, what does that mean? So this is where I have to interpret it. So to make 8 quarts of 18% antifreeze, we would use 6 quarts at 16% and 2 quarts at 24%. And again, I know that if you're wise, you can kind of look at this and figure it out without doing all this work. However, that only counts if it's whole numbers. If I give you some really funky decimal, like you need, I don't know, 5.236 quarts of something, and the other one, you're not going to be able to find that just using that guess and check method. The advantage to this method that we just did is that it will always work. And step 5, by the way, is just to check your answers. So you would check them over and make sure that they work. So I suppose we could do that. We could say, okay, 0.16 times 2, 0.16 times 6, plus 0.24 times 2, and I could find that with a calculator, right? Good. And just double check myself. 0.16 times 6 plus 0.24 times 2. Sure enough, that's 1.44. So our results appear to check out and make sense. Right? And it makes a little bit of sense on a different level, because you can say, okay, look, 18% is closer to 16% than 24%. So it makes sense that we used more of the 16% solution than the 24% solution. Let's think about it. I mean, if I said it was 20, if I wanted 20% solution, you'd be like, oh, 4 and 4 done, right? Because then it's perfectly even, right? Because you had 16 as your low, 24 as your high, so 20 is exactly in between. So if I had said, oh, I want 20% solution, you'd say 4, 4, and you wouldn't even have to do all this work. By doing 18%, I made it a little bit trickier. It's closer to the 16%, so you'd expect to use more of that 16% than you would of the 24%. That's kind of how you double check that it makes logical sense. You can always check back on the numbers. That's this part, just to make sure that the numbers you found actually work in the equations you made. Right? That's just double checking your work here for step 3. But you also want to make sure it makes logical sense. And that's that part here. All right, we're done with that question, and I'll meet you back here for the last one of this section, which is another mixture problem.